Hello everyone, my name is Baby, and in this video I'm going to demonstrate a simple Arduino project that allows you to move a character across an LED screen using 4 push buttons. And also this is an interactive project that helps us to learn about how to use the 12C LCDs and also use the LEDs and buzzer as a feedback. Moving on, I'd like to demonstrate the components or the things I used in making my circuit in the Arduino project. So moving on, I'd like to show you. So here are the components I used for this project. As you can see here, I have one Arduino Uno here. I have my I2C 16x2 LCD display here. I also have my breadboard. As you can see, I have 4 push buttons, which is indicated here, which I'll be using it for the up, down, left, right. And I also have one buzzer, one resistor, and a 220 ohms resistor here. And also you can see I have some jumper wires across my circuit. So now I would like to move forward and explain my setup. So now, as you can see, I'd like to explain the LCD first. As you can see on the LCD, we have our ground, our VCC, our SDA, and our SCL, where our ground will be connected we connected our ground to the ground on the Uno, and we connected the VCC to the 5 voltage, which means it supplies the LCD with 5 volts, and also connected the CSDA to A4, which we have on our Arduino board here, and we connected our SCL to A5, as you can see on the Arduino board. And also, as you can see, we have our 4 push buttons here, which I connected the first pin, the first push buttons, and positive or digital pin to pin 2, as you can see on the Arduino board, and the second push button to pin 4 on the Arduino board, and I connected the third to pin 8. Sorry, I connected it to pin 6, as you can see on the Arduino board, and I connected the fourth or the last push button to pin 8, as you can see on the push button, and I connected it negative side to the ground, as you can see here. I connected it to the ground by extending the ground from the motherboard to the breadboard. After, we have our buzzer on the motherboard. I connected the positive side or the digital pin to pin 10 on the Arduino board, and also connected its negative side to the ground, which was extended to the motherboard, as you can see here. So I connected its negative side to the ground. And now let's move up to our LED, which you can see on the breadboard. So with the LED, I use Arduino's internal pull-up resistor by setting the pins as input pull-up in code. And also I connected the positive side with a 220 ohms resistor and extended it to its digital pin, which we have on the Arduino board as pin 12, and also connected the negative side, which is the shortest side of the LED, to the ground. So I place it on the extension of the ground, which we have on the breadboard. So basically, all what these setups means is that when a button is pressed, the Arduino detects it and move the character we initialize, which is X, on the LCD screen. At the same time, it gives a visual and sound response using the LED and buzzer, which we have here. So when it's pressed, we see it gives us a sound with a buzzer, and also gives us light, which is a feedback for the user to know what he or she is doing. So now let's move on to our code and see what actually happens. So now I'll be taking you through my code. So first, I included the wire.h, which you can see on the first line. And I also included the LCD I2C.h libraries to work with the I2C LCD screen. I then created an object called Andy, which you can see here. Andy, which you can see. For the LCD, using the 12C address 0x27, as you can see on the fourth line, which we found using a scanner. Next, I defined which digital pins each button, the LED and the buzzer are connected to. So as you can see here, our up was put in a digital pin 2, the down was placed in a digital pin 4, we have our left to be placed in a digital pin 6 and our right to be placed in a digital pin 8. Also, you can see our LED was placed in a digital pin 12 and our buzzer positive side was placed in digital pin 10. I also declared two variables which we have here, which we have it as an int x, which is an integer, which is 0, and we also have our int y, which is an integer also 0, to keep track of the, so this is responsible to keep track of the current position of the x on the LCD screen. So now we move on to the void setup function. As you can see on line 17, I initialize the LCD and turn on its black light. As you can see, I also set all the buttons pin as input pull-ups, which means the buttons are active low. They read low when pressed. So you can also see I also set the LED and buzzer pin, which you have on line 27 and 28 as output. Finally, I called a custom function, which is the drawX, which you can see on line 30, to display the X at the starting position when the LCD is on. So now let's move into the void loop. So inside the loop function, I check if each button is pressed using digital right is equal to low. So as you can see here, and also if pressed and within screen limit, I updated the X or Y position accordingly and set a flag, move is equal to true. As you can see here, move is equal to true, as you can see under here. Also, if a move happened, I called drawX function to redraw the X in the new position, and I called flash LED and beep to give feedback, which is on the line 54, as you can see here. So now we are moving on to the void drawX function we have here. So in a void draw function, this function simply clears the LCD, sets the cursor to the current X and Y position, and prints the letter X on the LCD screen. Now let's move on to our void flash LED and beep function, as you can see on line 64. Finally, this function turns the LED on, plays a tone on the buzzer at 1000 Hz, waits for 100 milliseconds, then turns both off. So basically, in summary, the code reads input from buttons, update the LCD display based on position, and gives feedback using an LED and buzzer It's a great example for combining multiple Arduino features into a simple interactive interface. Now, let's move forward to demonstrate the circuit, whether it works or not. So now we're about to demonstrate our project to see whether our Arduino is right or not. So now let's see how it works, or let's see how our project works in real time. So now we need to connect our Arduino circuit to our PC to generate power to the Arduino. So now we connect using the USB cable which is connected to the Arduino. So we connect it to our PC. So when you connect it, you realize there is power entering into our Arduino board, where we see the light indicating green, showing power entry, and the orange color indicates the signal it receives. So now we need to run our code to test whether our Arduino project was successful or was a failure. So now we select our Arduino board and now upload our code. So now you can see our distance is done uploading. So now let's see on our board whether it shows a sign or it actually works. So you can see now, you can see the X. You can see the X indicating on the LCD screen. So we can see the X. So we told the code to put the X at the beginning of the LCD. So we can see our X at the beginning. So now basically this push button indicates the down, and this one indicates the up. This indicates the right and this indicates the left. So now let's see whether our push buttons, our buzzer and our LED actually works. And note, we made it in such a way when a push button is pressed, the buzzer gives a sound and the LED also gives a light to give the user a feedback to alert him that, oh, you've pressed a push button. So now let's see whether our this thing actually works. So now I'm pressing the down button, as you can see here. So you realize the light came, the sound came, and X, which was at the top, was now brought down. So let's press on the up button now and see. So you see, you realize now our X is now up. So now we have our left button here, but you realize the X is close to the edge, so it stops. So when we click our left button here, we realize nothing happens because the X is already at its end, so it can't move. So now let's click on the right button, as you can see here. So you realize now the X moved to the right. Let's press it one more time. You see. So you see the X move. So now we come back to the left, which we press and it didn't go. So now let's click on the left button now and see whether it will function. So now when I press on the left button, you realize it moved to the left. I press it one more side, you see it move. But when I press it again, you realize no feedback comes because it's at its end, so it cannot move. So now since our buttons are all functioning, which you can see, we can now see our project was a successful project. So that's basically it. Now we can say our project was a success. So thank you for watching, and I hope you found this project interesting. Bye.